Good day everyone, and welcome to where we are putting together solutions in additional mathematics in CSEC, Caribbean Secondary Examination Council. In this video, we'll be looking at the past paper question Me 2023, paper 2. Don't forget to like the video and add any comments down below so we can help create other videos to assist you in this subject. If you look at the description down below, we have outlined 4 areas of the syllabus and the order to which you must go through it in order to get a better grasp of the entire additional mathematics syllabus. May 2023, number 1A. Solve the equation 3 to the power 2x plus 1 minus 5 times 3 to the power x minus 2 is equal to 0. Giving your answer to 3 decimal places. So let's rewrite the equation. Let's see if you can break up the first term such that it will be 3 to the power 1 times 3 to the power 2x. So we can rewrite it again in the form 3 to the power 1 by 3 to the power x squared, because when we have the powers, then we can multiply them. X times 2 is 2x. Minus 5 times 3 to the power x minus 2 is equal to 0. So we can easily use a substitution here. So let m is equal to 3 to the power x. Then if we substitute, we're going to get 3 to the power 1, which is 3, by m squared minus 5m minus 2 is equal to 0. And now we have a quadratic equation equal to 0, so we can either use the quadratic formula or we can factorize. So let's factorize. That will give us 3m plus 1 by m minus 2 is equal to 0. As such, either the first bracket 3m plus 1 is equal to 0, which means 3m is equal to minus 1, so m is equal to minus 1/3. And if we substitute back for m, it means 3 to the power x is equal to minus 1/3. And the graph 3 to the power x will only have positive values. As such, there is no solution for this. So let's try the other brackets. M minus 2 is equal to 0, so m is equal to 2. And therefore 3 to the power x is equal to 2. So we can solve using logarithms. So let's log both sides. It will give us x is equal to log 2 to base 3. And if we're using our calculators, it means x is equal to log 2 divided by log 3, which works out to be 0.631. So if we substituted x to be that value in the original equation, it will work out to be 0. B, part 1. Given that 3x plus 2 is a factor of 3x cubed plus bx squared minus 3x minus 2, find the value of b. So if 3x plus 2 is equal to 0, 3x is equal to minus 2, which means that x is equal to minus 2/3. So let f of x be the function 3x cubed plus bx squared minus 3x minus 2. And if we substitute for x being equal to minus 2/3, because that is when 3x plus 2 is a factor, it will give us f of minus 2/3 is equal to, let's substitute, 3 by minus 2/3 cubed plus b by minus 2/3 squared minus 3 by minus 2/3 minus 2. And since it's a factor, that will work out to be 0 is equal to minus 2 cubed will be minus 8 over 27 times 3, which will be minus 8 over 9, plus b times minus 2/3 squared, which will give us 4/9 b, plus minus 3 times minus 2/3, the 3's cancel, so it'll give us plus 2, minus 2. So we can now solve for that. Since 2 minus 2 is 0, we can carry the minus 8/9 across, so it'll give us 8 over 9 is equal to 4 over 9b. It means 8 is equal to 4b, so b is equal to 2. So when b is equal to 2, 3x plus 2 is a factor of that function. B part 2, hence factorize completely 3x cubed plus bx squared minus 3x minus 2. So let's rewrite the equation. 3x cubed plus 2x squared minus 3x minus 2 is equal to, and since we want to get a cubic equation, then it'll be 3x plus 2 by a quadratic, which is bx squared plus qx plus r. And there are a couple of different ways to do this. So let's multiply using the box method. So if we consider that the length of this box is px squared plus qx plus r, and the width of the box is 3x plus 2, we're basically finding the area of each of the smaller rectangles. So for the first rectangle up on top, 3x times px squared will give us 3px cubed. And then for the second rectangle, which we have in blue, will be 3x times qx, which will give us plus 3qx squared. And for the third rectangle, which we have in brown, it'll be 3x times r, which will be plus 3rx. And for the second row, plus 2 times px squared will give us plus 2px squared, which we have in blue. And the reason we have those in blue, those two will be the terms in x squared. And for the middle box below, it'll be 2 times qx, so it'll be plus 2qx. And we have those two in brown because those are the terms with x in it. And the last box, 2 times r, will give us plus 2r. So if we equate the coefficients, then in terms of x cubed, we know 3px cubed, which is what we got in the box, is equal to the original equation 3x cubed. As such, p is equal to 1. So we found p. Let's do the same for the boxes that are blue, which are the terms with x squared in it. So 3qx squared plus 2px squared is equal to what's in the original equation? Bx squared, and b worked out to be 2. So that will be 2x squared. If we divide throughout by x squared, it means 3q plus 2p, and we know p is 1, so 2 ones are 2, is equal to 2. So if we carry the 2 across, we get 2 minus 2 is 0. 3q is equal to 0, so therefore q is equal to 0. So the middle term is 0. And for the term without x in it, we can use 2r, which is from the box, is equal to minus 2, the original equation. As such, r is equal to minus 1. So we found for p, q, and r, which means that when we rewrite the equation, it will be 3x plus 2 by p is 1, so 1x squared. Q is 0, so you could leave out the middle term, minus 1. So we get 3x plus 2 by x squared minus 1. We could have also solved for the middle term using the boxes which are brown, the terms in x. And if we had done that, it would give us 2qx plus 3rx is equal to minus 3x. And we knew r to be minus 1, so we could have substituted. We get 2q plus 3 by minus 1, which is minus 3, is equal to minus 3. Minus 3 when you carry it across would be minus 3 plus 3 is 0, so q would still work out to be 0. So if we use the terms in x squared, the blue boxes, to compare, or we use the terms in x, which are the brown boxes, it would still give us q is equal to 0. And we'd still end up where we are, 3x plus 2 by x squared minus 1. And of course, we can factorize that quadratic because that is the difference of squares. So the complete factorization of the cubic equation is 3x plus 2 by x plus 1 by x minus 1. May 2023, number 1C, determine the value or values of p, for which the function px squared plus 3x plus 2p has two real distinct roots, giving your answer in its simplest form. So we know the general form of a quadratic equation is ax squared plus bx plus c, where a is the coefficient of x squared, which in this term is p, b is the coefficient of x, which is plus 3, and c is the term without x, or with the x to the power 0. So c works out to be 2p. So let's recall the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And from the quadratic formula, we can say that we replace b squared minus 4ac as d. So d is equal to b squared minus 4ac, which must be greater than 0 if we're going to have two real distinct roots. And we can simply substitute because we have them color-coded up above. So it'll give us 3 squared minus 4 by p by 2p is greater than 0, which means 3 squared is 9 minus 8p squared is greater than 0. So 9 is greater than 8p squared. So 9 over 8 is greater than p squared. So the square root of that will be plus or minus 9 over 8 is greater than p. And we can break up 8 into 4 times 2. So we can rewrite it plus or minus 3 over the square root of 4 times 2, which is plus or minus 3 over 2 root 2 is greater than p. So that means minus 3 over 2 root 2 is greater than p, which is greater than 3 over 2 root 2, except when p is equal to 0. When p is equal to 0, that function works out to be 3x alone, which is a straight line. So it will only have one root. And we can indicate it by the following number line as well. May 2023, number 2a, given that the function f of x is equal to 3x squared minus 9x plus 1. Part 1. Express f of x in the form a, x plus b squared plus c, where a, b, and c are real numbers. So we're trying to complete the square. And there are a couple different ways to do this. We're going to use the algebraic tiles to show how to complete the square. So f of x is equal to 3x squared minus 9x plus 1. And let's factorize out the 3 from the terms in x. So it will give us f of x equal to 3 by x squared minus 3x plus 1. And what does that really mean? It means we have 3 sets of the terms in brackets. So we can rewrite it. F of x is equal to x squared minus 3x plus another x squared minus 3x plus another x squared minus 3x plus 1. So we're considering the curly brackets, x squared minus 3x. So let's bring up x squared in as a yellow square, which means the length is x and the breadth is x. X by x is equal to x squared. And we want to get minus 3x. So we can bring up x on the right-hand side, which means it's x times minus 1 will give us minus x. And the way we indicate negative in algebraic tiles is using a red tile. And if we have minus 1x on the right side, we need to put minus 1x below. So that will be minus 1 times x. And what that means, you can notice that it moved from the yellow, which was a square, and we're trying to grow towards a bigger square. So we're moving to the right by minus 1 and down by minus 1 as well. So what do we have right now? X squared minus x, which means x squared minus 2x. We're still missing another minus x term to make it minus 3x. And since we want to maintain that square, then we can split it in 2. So we're going to get minus x on 2 on the right-hand side, which means x times minus a half. And similarly below, we're going to get minus x on 2, which means x on 2 as a red tile, which is minus a half times x. So now we can form a big rectangle whose width and length is x minus 3 over 2, or x minus 1.5. Now, in order to get the complete terms, we have 3 sets of these. That's for the first curly brackets. Let's now add a second one to get the second curly brackets, a third one to get the third curly brackets, each being x squared minus 3x plus 1. And if you notice, the 1 there is in green and not red, because red would indicate minus 1. We have plus 1 there. So now, how do we fill those little spaces in each of those squares? So if you look at the square, we can see plus 1 and minus 1, plus a half and minus a half, plus a half and minus a half, and what we mean, plus a quarter and minus a quarter. So what do we really have there? We have 1 plus a half, which is 2, plus a quarter. So we have 2 1/4 minus 2 1/4. 2 1/4 minus 2 1/4 is equal to 0. So what we're really adding to this first square is 0. So it doesn't change in terms of its overall value. And we can now slide those terms into place. If we're trying to fill that big square, it'll be -1 times -1, which is +1. So let's slide the +1 across. And then -1/2 times -1 is +1/2. So let's slide that up to the right. And then -1/2 times -1 is +1/2. Let's slide the next half across. And then -1/2 times -1/2 is 1/4. So we could slide it across. So we took all the positive terms, and that completed our square. And let's do the same thing for the second one. Let's bring up all the positive and negative terms, which is still 2 1/4 minus 2 1/4, which works out to be 0. And we can fill this space as well. So we've completed the square in the first case, in the second case, and we'll do it in the third case as well. So what do we have in all? In the first case, we have x minus 1 1/2 by x minus 1 1/2, so x minus 1 1/2 squared, minus 2 1/4, which are the red terms that's remaining outside. And we have 3 sets of those. So we can write that the function f of x is equal to 3 by x minus 1 1/2 squared minus 2 1/4 plus 1. Don't forget the last square on the right side. And now we can bring the 3 inside the curly brackets. So it'll give us 3 by x minus 1 1/2 squared minus 6 3/4. 3 2s are 6. 3 times 1/4 is 3/4 plus 1. So we can simplify f of x is equal to 3 by x minus 1 1/2 squared minus 5 3/4. So we found A, B, and C. A is 3, B is minus 1 1/2, and C is minus 5 3/4. Part 2. State the coordinates of the minimum point of f of x. So for f of x to be the least value, then the brackets which are being squared must work out to be the smallest possible value. And the smallest possible value for brackets which are being squared is 0. It can't become negative because it's being squared. So we can write that x minus 1 1/2 is equal to 0. As such, x is equal to 1 1/2. So when x is equal to 1 1/2, we're going to be at our minimum point of this quadratic equation. And if we want to find the y value, let's substitute into f of x. F of x is equal to 3 by x minus 1 1/2 squared minus 5 3/4. And when x is equal to 1 1/2, then the brackets become 0. So we're left with minimum value of f of x is equal to minus 5 3/4. As such, the coordinates of the minimum point of f of x is 1 1/2 minus 5 3/4. May 2023, number 2b. The equation 3x squared minus 6x minus 2 is equal to 0 has roots alpha and beta. Find the values of 1 on alpha plus 1 on beta. So let's rewrite it, and let's color code the coefficients so it's easy for students to identify. We'll write it over where we have the coefficient of x squared in red as a being equal to 3, b is equal to minus 6, and c is equal to minus 2. Because let's recall, the general equation of a quadratic is ax squared plus bx plus c. So the sum of roots of a quadratic equation is equal to minus b over a. So we can simply substitute. It'll give us minus of minus 6 over 3. Minus 6 is 6 over 3. 3 into 6, 2. And the product of the roots is equal to c over a. And if we substitute, it'll give us minus 2 over 3. So we know the sum of the roots, which is alpha plus beta. And we know the product of the roots, which is alpha beta. So we want to find for 1 on alpha plus 1 on beta. So we're simply adding 2 fractions. So if we add the fractions, the denominator will become alpha beta, and the numerator will be beta plus alpha, which means beta plus alpha is the sum of the roots, and alpha beta is the product of the roots. So we have the numerator and denominator we can substitute. So that will give us 2 divided by minus 2/3, which is equal to 2 over 1 times minus 3 over 2. The 2's cancel, so we're left with minus 3 over 1, which is minus 3. So 1 on alpha plus 1 on beta is equal to minus 3. Part C, last part of the question. John's grandparents started a university fund for him at a bank with $4,000. The bank offered two options for interest. Option 1, $240 per annum, which means per year, or option 2, 5% of the current balance per annum. Determine the sum of money in the university fund at the beginning of the 9th year for both options. So beginning of the 9th year means it got 8 years of interest. So in option 1, his starting principal was $4,000 plus 8 years at $240, which works out to be $5,920. And in option 2, we want to get the sum of the GP. So S to the n is equal to A, R to the n minus 1 over R minus 1. And we want to find S to the 8. So that is 4,000. Well, that's what you're starting with, the principal. And since we're getting 5% per annum increase, R, the common ratio, will be 1.05 to the power 8 minus 1 over 1.05 minus 1, which works out to be $5,909.82. So we've gotten the total sum at the beginning of the 9th year for both options. May 2023, number 3a. The equation of a circle is equal to x squared plus y squared minus 8x minus 18y plus 93 is equal to 0. Part 1, determine the coordinates of the center of the circle. So let's bring up a circle so you can see what it looks like. So let's rewrite it. X squared minus 8x plus y squared minus 18y plus 93 is equal to 0. We're putting the x's together and the y's together. And pretty much what we're doing, we're trying to complete the square for the terms in x and similarly for the terms in y. Well, the easiest way to do that will be to split the middle term. So x squared minus 8x, the term we have in red, half of it will be minus 4. So we can add minus 4 squared and take away minus 4 squared. So if we're adding and taking away the same term, then the total will be 0 for that part. So we're not actually changing the value of the equation. And similarly, y squared minus 18y plus, look, we have minus 18 in green, so that's what we're using. Half of that is minus 9. So we're going to say add minus 9 squared, subtract minus 9 squared. Plus 93 is equal to 0. And let's put square brackets around the first three terms. X squared minus 8x plus minus 4 squared minus minus 4 squared plus, let's do the same for the next three terms. Square brackets around y squared minus 18y plus minus 9 squared minus minus 9 squared plus 93 is equal to 0. So the square brackets works out to be x minus 4 all squared minus, what's minus 4 squared? 16 plus, for the next set of square brackets, y minus 9 all squared minus 81 plus 93 is equal to 0. So minus 97 plus 93 is minus 4, so we can carry it across. So we rewrite it x minus 4 squared plus y minus 9 squared is equal to 4. As such, the center will be x is equal to 4 and y is equal to 9. So we can bring that up in the graph. Part 2, find the length of the radius. So the radius will be the right-hand side, whatever value that is equal to r squared. So r squared is equal to 4, which means the radius r is equal to the square root of 4, which is 2 units. And we can clearly see, if we're looking at the center being 4, 9, and the radius is 2 units, that means that if we went 2 to the left, then one end of the circle is 2, 9, and we can see that's happening. To the right, it will be 6, 9. If we go up, it will be 4, 11. And if we come down, it will be 4, 7. So you can see that the circle and the center make sense. Part 3, find the equation of the normal to the circle at the point 2, 8. So if we bring up 2, 8, we can see it doesn't lie on the circle. But if we draw that line from 2, 8 to 4, 9, we can see that it's going towards the center. So we want to find the equation of that normal. So let's bring up a triangle where we can see that if we're moving from the left at 2, 8 to the center, 4, 9, then we're moving 2 units to the right. So we can say the change in x values is equal to 2. and then we're going up. So the change in y values is 1. So since the change in n is change in y over change in x, then we can substitute. It'll be 1 over 2. So we know the gradient of the normal is plus a half. And we can see that we're on the right track, because if the gradient is positive, it means the line is sloping up to the right. So let's solve for the equation. Gradient of n is equal to change in y over change in x. So we can substitute. Gradient in n is a half is equal to, what's the change in y? Y minus any point that we're using. We can either use 2, 8 or 4, 9. So let's use the center. So y minus 9 over x minus 4. We're using the x and y values there. So we can now solve by carrying the denominator across. It will give us a half by x minus 4 is equal to y minus 9. So we can expand. So it will give us a half x minus a half times 4 is 2 plus 9 is equal to y. So y is equal to half x plus 7. May 2023, number 3b. The position vectors of 2 points A and B relative to an origin O are such that OA is equal to 3i minus j. So let's bring up a little sketch of a graph and bring up the point O being the center or the origin. And if it's 3i minus j, it means you're going 3 units to the right and 1 unit down. So we can draw a green line from O to A, give us a general idea of what the vector OA represents. And OB is equal to 5i minus 4j. So similarly, let's bring up B at the point where I, the unit vector in the x direction, is 5, and the unit vector in the y direction is minus 4. So we're just kind of averaging here, so students could get a general idea of what's happening. And now we can draw the line O to B, that vector. Determine, part 1, the unit vector AB. So let's draw a line from A to B. So if we want to go from A to B, we can pass from A to O plus O to B. So we have that equation for our vectors. And we don't actually have AO, but we have OA. And what's the difference? One is the negative of the other. So we can replace it. AB is equal to minus OA plus OB. And we can substitute. So AB is equal to minus, and what's OA? 3i minus j plus OB, which is 5i minus 4j. So if we expand, it'll give us minus 3i plus 5i. We keep the i's together, the unit vector for in the x direction, plus j minus 4j. And we can simplify. So AB is equal to 2i minus 3j. So if we start at A and we move 2 units to the right and then 3 units down, it will give us AB. And we can indicate that by that triangle, showing change in x is 2 and change in y is minus 3. Now, since we want to find the unit vector, it means we need to find the length of AB. And we have a blue triangle showing AB, so we can use Pythagoras' theorem, which is change in x squared plus change in y squared is equal to the length of the hypotenuse squared, AB squared. So we can write AB squared is equal to change in x, which is 2 squared, plus change in y squared, which is minus 3 squared. So 2 2s are 4, plus minus 3 by minus 3 is 9, 4 and 9 is 13. So AB squared is equal to 13, so the length of AB, or the modulus of AB, is the square root of 13. As such, if you want to get a unit vector of AB, it will be the vector AB divided by its modulus, or its length. So that will give us 2i minus 3j over the square root of 13. That's the unit vector of AB. Part 2. Determine the acute angle AOB in degrees to 1 decimal place. So let's bring up a little red arc to show AOB. So if we're going from A to O and then O to B. So if we're using the scalar product, remember for the scalar product to get that red value, either both vectors will be going in to meet at O, so it'll be AO dot BO, or we can use both vectors coming out of O, so OA dot OB. So we already have OA and OB, so let's use that. So OA dot OB, meaning scalar product, is equal to the length of OA times the length of OB cos theta. And we can substitute accordingly. So that will give us 3 minus 1, because we know OA is 3i minus j. dot 5 minus 4, because OB is 5i minus 4j, is equal to the length of OA, and let's work that out quickly. To go from O to A, we're moving 3 to the right and 1 down. So using Pythagoras' theorem, then it'll give us 3 squared, which is 9, plus minus 1 squared is 1. 9 and 1 is 10. So the length of OA will be the square root of 10. You can do the same working as we did to find the length of AB down below on the left side. Similarly, the length of OB will be 5 squared, which is 25, plus minus 4 squared, which is 16. 25 plus 16 is equal to 41. So the length of OB is the square root of 41. Cos theta, theta being that angle we have indicated in red. And how do we work out the scalar product or dot product? Well, we multiply the top terms, which is the term in red by the term in black, plus the bottom terms, the term in green by the term in blue. We're using the different colors so students can follow this explanation. So 3 by 5 plus minus 1 by minus 4 is equal to square root of 10 by square root of 41 is square root of 410 cos theta. So 3 by 5 is 15, plus minus 1 by minus 4 is plus 4, all over the square root of 410 is equal to cos theta. So theta is equal to 20.2 degrees. May 2023, number 3C. Solve the equation 2 sine squared theta is equal to 3 cos theta, where 0 degrees is less than theta, which is less than 180 degrees, meaning that we're only looking for values of theta in the first or second quadrants. So let's rewrite the equation 2 sine squared theta is equal to 3 cos theta, and we can convert sine squared theta into a form dealing with cos squared theta. Remember, sine squared theta plus cos squared theta is equal to 1. So that means sine squared theta is equal to 1 minus cos squared theta. So we can substitute for that. So 2 times 1 minus cos squared theta is equal to 3 cos theta. And if we expand, it will give us 2 minus 2 cos squared theta is equal to 3 cos theta. And if we move everything across to the right-hand side, 0 is equal to 2 cos squared theta plus 3 cos theta minus 2. So it looks like a quadratic equation equal to 0. So if we're solving for that, we can either use the quadratic formula using the coefficients 2, 3, and minus 2, or we can factorize. So if we factorize, it's going to give us 0 is equal to cos theta plus 2 by 2 cos theta minus 1. And if we're solving for this, either the first bracket is equal to 0, which means cos theta plus 2 is equal to 0, where cos theta will be equal to minus 2. And if we recall, for the cosine graph, the maximum value is plus 1 and the minimum value is minus 1. So if cos theta works out to be minus 2, it doesn't fall on the graph. As such, there's no solution for theta here. So let's try the second brackets. Or 2 cos theta minus 1 is equal to 0. So 2 cos theta is equal to 1. Therefore, cos theta is equal to 1 over 2, which is a half. So theta is equal to 60 degrees. Theta is also equal to 300 degrees, but that doesn't fall within the range from 0 to 180. So we'll just use the one value that theta is equal to 60 degrees, solves the equation 2 sine squared theta is equal to 3 cos theta. If we substitute theta into sine theta there, sine theta or sine 60 is root 3 on 2. When we square it, we're going to get 3 over 4 times 2, which works out to be 3 over 2. And if we say on the right-hand side, 3 cos theta will be 3 times a half, which is 3 on 2. So the left side and the right side works out to be the same. Part D, last part of this section. Prove the identity 1 over 1 minus sine theta minus 1 over 1 plus sine theta is equal to 2 tan. So we can use either the left side or right side. So we'll recall on the left-hand side that 1 over 1 minus sine x minus 1 over 1 plus sine x. So we pretty much have two fractions that we're subtracting. And the simplest way to do it is find the common denominator, which will be 1 minus sine x by 1 plus sine x. And that will give us 1 plus sine x minus 1 minus sine x in the numerator over 1 minus sine x by 1 plus sine x in the denominator. And we can remove the brackets, so it will give us 1 plus sine x minus 1 plus sine x all over, and you can see that's like the difference of squares. 1 minus sine x by 1 plus sine x is 1 minus sine squared x. So the top works out to be 1 minus 1 is 0, so plus sine x is 2 sine x over 1 minus sine squared x is cos squared x. So we can break that up. It'll give us 2 sin x over cos x times 1 over cos x. Because the numerator still works out to be 2 sin x and the denominator still works out to be cos squared x. And 2 times sin x over cos x is 2 tan x all over cos x, which is equal to the right-hand side. So we can bring up a little square or write QED, quod erat demonstrum, the Latin phrase, to show that we have proven the identity. May 2023, number 4a. A function given by ax squared plus bx plus c, a quadratic equation, has a gradient of 9 minus a half x at a stationary value of 5. Part 1. Determine the values of a, b, and c in the function. So we know the gradient, dy dx, is equal to 9 minus a half x, and we know it's at a stationary value, which means that dy dx is equal to 0. So 0 is equal to 9 minus a half x, which means a half x is equal to 9, so x is equal to 9 times 2, which is 18, when y is equal to 5. So x is equal to 18 when y is equal to 5 at the stationary value. So since dy dx is equal to 9 minus a half x, we can integrate both sides with respect to x. So the integral of dy dx with respect to x is the integral of 9 minus a half x with respect to x, which on the left-hand side, that will give us y is equal to 9x minus a half x squared over 2. So in the denominator, 2 times 2 is 4, so that'll give us minus a quarter x squared plus c. And at the point x equal to 18 and y equal to 5, we can substitute. So 5 is equal to 9 by 18 minus a quarter times 18 squared plus c. C is equal to minus 76. As such, a is equal to minus a quarter, b is equal to plus 9, and c is equal to minus 76. We've determined the values in the function. Part 2, determine the nature of the stationary point. So in order to do that, we can double differentiate it. So d2y dx squared is the differential ddx of dy dx. So if we substitute ddx of 9 minus a half x, which works out to be minus a half. Since d2y dx squared is negative, it means it's a maximum turning point. May 2023, number 4b. A drone tracks the movement of an object in motion on the ground. The following movements are recorded. It moves at a constant velocity of 4 meters per second for 5 seconds. Its velocity increases uniformly for 3 seconds to 10 meters per second. It moves at that velocity for 7 seconds. Part 1. Sketch a graph of the movement of the object. So let's bring up a graph of velocity in meters per second versus time, and the important values accordingly. So we know that it's starting at 4 meters per second. So when time is 0, the velocity is 4, and it continues at this for 5 seconds. So we can bring up that point and draw a line from the first x to the second, indicating that the velocity remained constant for 5 seconds. And that distance it covered within that period, we will call that S1, distance for the first part. And then what happened? Its velocity increases uniformly, means it's accelerating positively. So the graph is going to go upwards for 3 seconds to 10 meters per second. So you can bring up that point. 5 plus 3 is 8. So at the point where time is 8 seconds and velocity is 10 seconds, you can now draw a line from 5 to sloping upwards to the right. And for the last part, it moves at that velocity for 7 more seconds. So it's remaining constant for 7 more seconds. 8 and 7 is 15. So at 15:10, where the time is 15 and the velocity is 10, you can draw a line across to indicate that motion. Part 2. Calculate the distance traveled by the object in the second part of the journey. So that distance is what we're trying to find is S2. So that shape is a trapezium. So the formula is a half a plus b by h. So we can substitute a half times what's the perpendicular distance between the two parallel lines from 5 to 8, that's 3. So a half times 3 times 5 plus 8, the length of the two parallel lines. So 5 plus 8 is 13, 13 by 3 is 39, Half of 39 is 19.5. So the distance traveled in the second part of the journey is 19.5 meters. Part 3. Determine the object's acceleration in the final part of the journey. So acceleration is change in velocity over change in time. And in the final part of the journey, the change in velocity was 0 because it was a flat line. So it will be 0 over 7 means that the acceleration is 0 meters per second squared. As such, it didn't accelerate, but it maintained a constant velocity for the final part of the journey. May 2023, number 5A. Consider a toy truck moving along a miniaturized racing course with an acceleration of a with respect to t equal to 9t squared plus 2t minus 1, where t is the time in seconds. Assume that the speed of the truck is measured in centimeters per second. Part 1. Outline how an equation for the speed of the truck would be found using the given equation for the acceleration. So the given equation is a is equal to 9t squared plus 2t minus 1. And how would we find the velocity? As we recall from the formula sheet, the velocity is just the integral of a with respect to t. So the way we would find the velocity is just by integrating the acceleration. Part 2. Find the speed of the truck at t is equal to 10 seconds. So if the velocity is equal to the integral of a dt from part 1, and we can substitute for a because a is 9t squared plus 2t minus 1. So it will be the integral of that, which gives us 9t cubed over 3, which is 3t cubed, plus 2t squared over 2, which 2 cancels 2, which will be t squared, minus t plus c. So that's the velocity. And when t is equal to 10 seconds, the velocity is 3 by 10 cubed plus 10 squared minus 10 plus c, which is 3 times 1,000 is 3,000, plus 100 is 3,100, minus 10, so it will be 3,090 plus c. Part 3. Find the distance covered by the truck between 5 and 10 seconds. Express your answer to the nearest whole number. So we want to find the distance, knowing we have a formula with velocity. So s is equal to the integral of v with respect to t between the limits of 5 and 10. So we can substitute s is equal to the integral of 3t cubed plus t squared minus t plus c between those limits. So the integral of 3t cubed plus t squared minus t plus c will give us 3t fourth over 4 plus 1/3 t cubed minus a half t squared plus ct, the concept of integration from part 2, between the limits of 5 and 10. And if we substitute, it's going to give us 3/4 by 10 to the power 4 plus 1/3 by 10 to the power 3 minus a half by 10 squared plus 10c minus 3/4 by 5 to the power 4 plus 1/3 by 5 cubed minus a half by 5 squared plus 5c. Now at this point in time, we won't be able to solve for this because the c's won't cancel. And since they're asking us to express our answer to the nearest whole number, we shouldn't have any constants of integration in there. Therefore, there's a mistake in the question. So the question cannot be solved according to what information was given. However, if we were to assume that the truck started from rest, then when time is 0, v is 0. And in that case, in part 2, then c, the constant of integration, would work out to be 0 as well. And in this case here, if c is 0, then we would have ended up with the same line that we have where c is 0, that would disappear. And then we can solve to find the distance in centimeters. But we can't make that assumption because nowhere in the question was it indicated that the toy truck started from rest. So this question cannot be solved according to the information that's given. May 2023, number 5b. Integrate 2x plus 3 squared with respect to x. There are a couple different ways to do this. So one way is just to expand the bracket. So it'll give us 4x squared plus 12x plus 9. And if we integrate that, it'll give us 4x cubed over 3 plus 12x squared over 2, which is 6x squared, plus 9x plus c. And for students who get in a little trouble by expanding, we can use the box method, where we bring up a box of 2x plus 3 by 2x plus 3, length and breadth. And we can find the area of each of these smaller rectangles. 2x by 2x is 4x squared. 2x by 3 is plus 6x. 3 by 2x is plus 6x plus 9. So that works out to be 4x squared plus 12x plus 9. That's how we got our second line. Part 2. Integrate 5 cos 2x dx. And if we recall that the integral of cos ax dx is equal to 1 on a sine ax plus c, where a is 2, and we have a constant of 5 in front, that will give us 5 over 2 sine 2x plus c. Part C. If dy dx is equal to 6x minus 10, and y is equal to 12, when x is equal to 0, find the equation for y in terms of x. So dy dx is equal to 6x minus 10, and if you integrate both sides with respect to x, it will give us y is equal to 6 on 2x squared minus 10x plus c. And we know that the point passes through x is equal to 0, y is equal to 12. So if we substitute, 12 is equal to 2 into 6 is 3. So 3 times 0 squared minus 10 times 0 plus c. Therefore, 12 is equal to c. So we can now solve y is equal to 3x squared minus 10x plus 12.
May 2023, number 6, part A. The following stem and leaf diagram represents the scores. And if we look at our diagram, we can see that in the first column, those values from 3 to 7 indicates a place value of tens. So that means 30s, 40s, 50s, 60s, and 70s. And the second column of items coming down indicates the unit values. So the key represents this by showing us that if we have 4/6, it means that there are 4 tens and 6 ones, or it has a place value of 46. So since this represents the scores out of 80 of students in an additional mathematics exam, part A, write the raw data set that was used to construct the diagram above. So we have the stem and leaf diagram, and we would like to work backwards to indicate what are the raw set of data. So if we notice, indicating the first row, there's a 3. So there's 3, 0, 3, 3, and 3, 7. So that means we have 3 numbers in the 30s, we have 5 numbers in the 40s, and so on. So this shows us that we have 9 and 8, 17 students who wrote the examinations, with the lowest mark being 30 and the highest being 79 out of 80. As we move on, in part B, determine the following measures for the data set. So we want to first of all find part 1, the median exam score. So if we notice that in the raw data set, we have the numbers written out from the lowest to the highest, or we can say in ascending order, then for 17 numbers, the median or middle will be the 9th number, which we can tell is 51 if we're looking at it from the stem and leaf diagram. And if we're looking at the raw data set, it will be the same. So there'll be 8 numbers before the 51 and 8 numbers after the 51. So the median exam score is clearly 51. And as we move on to the second part, find the mean exam score. And to find the mean of these numbers, then we need to add up all the numbers, which will give us 885, and divide it by the amount of numbers, which is 17. So 17 into 885 is 52.05. As we move on now to part 3, determine what is the modal score or scores. So if we look at the set of data, we can see there's one value of 30, one value of 33, and we continue like that. And then we see 2 values of 53 and also 2 values of 67. This is considered to be a bimodal set of data, meaning that there are 2 data values which are the modes. They are 53 and 67. they both occur twice. Part 4, state that for the data set sigma x squared is equal to 48,999, that is given, and sigma x is equal to 885, which we had used in part 2. Find the standard deviation of the data set using the formula. So the formula is such that the standard deviation is equal to square root of sigma x squared minus sigma x all squared over n. N is the number of terms, which in this case is 17, all over n minus 1. So we simply have to substitute because they gave us sigma x squared, which is each of the terms squared and then finding the total. So that is 48,999 minus sigma x is 885 squared divided by 17 all over 17 minus 1, which is 16. So that works out to be 48,999 minus 46,072 divided by 16. And this works out to be 13.53. This represents the standard deviation for this data set. Part C. If a student needed to score at least half the total marks, and remember the total is 80, so if they had to score at least 40 marks, pass the exam, determine the probability of a student failing the exam, giving your answer to 2 decimal places. So if we know that the total is 80 and the pass mark will be half of it, which is 40, how many students failed the exam? Well, let's indicate that with a little purple rectangle so we can see it will be those students who got 30, 37, and 33. As such, that would be 3 students out of the total number of students, which is 17. And since they want their answer to 2 decimal places, this gives us 0.18. Part D, given that a randomly selected student has passed the exam, what is the probability that the student scored over 60? So, if we look at the fact that there were 3 students who failed the exam, then what is the data of the students who passed the exam? It will be those with this little green background, which is 14 students. So out of these 14 students, how many students got over 60? That will be 67, 67, 71, and 79. 4 students out of the 14, because 14 students passed the exam. So that probability would be 4 over 14, which is equal to 0.29. This can also be done a little differently because of the first word being a key indicator, that word being given. Since it's given, then we can also solve this question using conditional probability, which we have done in previous past papers. And in a case like that, we will be comparing the number of students who got over 60 out of the total, which is 4 out of 17, and that will be in comparison to the number of students who passed out of the total, which is 14 out of 17. So by substituting into the conditional probability equation, we'll get 4 out of 17 divided by 14 out of 17, which works out to be exactly the same as what we have, 4 out of 14 or 0.29. And we go on to part E. Based on the stem and leaf diagram, describe the distribution of the data set. If we look at it, we can see where the median is, or Q2, and that is 51. The minimum value is 30. So the difference between the minimum value and Q2 is 51 minus 30, which is 21. And if we compare the difference between 51 and the maximum value, which is 79, that is 28. As such, we can see the data is positively skewed, which means that it is skewed to the right. And why is that? because the distance from Q2, 51, to the maximum, which is 79, is greater than the distance from 51 to 30. And for the last part of the question, and to complete the past paper, your friend suggested a bar graph or histogram could be used to represent the data. Advise your friend on which graph is the better option, giving one reason to support your answer. A bar graph would be a better option as the data set consists of what sort of data? It consists of discrete data. While when using a histogram, that is normally used to represent continuous data.
We've now come to the end of CSEC past paper questions, paper 2 for the year May 2023. Don't forget to look at the description below where we have outlined the order we suggest that you go through the entire CSEC additional mathematics syllabus for you to get a better grasp of the entire subject area.